Hi. Now today is Copy Edit Wars Part 2, or of 2 parts, I guess, of continuation of the story from Wednesday. And let's see. First, I better start by making a correction to what I said. I noticed another letter in the file after class. I had said that my paper was accepted in January of '76, and then the next I heard was February '77 with a copy edited review asking for quick service all of a sudden. But no, that's not true. I got a letter on December 23rd, 1976. So this must have arrived during a little after Christmas vacation. Saying, I'm sure you've been wondering what's happened to the article you were kind enough to write at our request. At long last, we have an opportunity to present it, and it will go in the April issue of Scientific American. I've always liked April issues, so this was good. It goes to press in about 2 months. This one's so now we will shortly undertake to edit the article. A retyped copy should be in your hands by the end of January. It was pretty close. As I have indicated, you may correct or further rework that copy totally as you see fit. While I'm at it, I'd like to ask you a favor, biography, and please send this by December 31. Now, I bring this out now because it talks about deadlines and publication and everything, and you all have a deadline of next Wednesday that was announced quite well in advance. And this is the day when we want your term papers drafts to be definitely turned in. This is because copies are going out to the different readers. I mentioned Mary Claire has agreed to look at them, and also Rosalie Stemmer and us. So we can't. It's just like the printing industry. We can't accept a delay that gets us out of this, that gets the cycle out of it. Now, in fact, Scientific American was amazingly good at their deadlines. I was surprised. I mean, a lot of the things that I've been talking about all went on in the space of 2 weeks. Jack?
Do we have to submit 6 camera-ready copies of our?
No. We are going to take care of the cost of reproducing the extra copies, but you'll get back more copies than you turn in. And if your paper has a lot of graphics in it, no, it's not three-dimensional graphics, right? So if it's Xeroxable anyway, that's what. If it's something that isn't easily reproducible, then we'd appreciate extra copies. But otherwise, we plan to what? Color. Yeah, that's right. We don't have a good color copier right here, so. So this took place in a short period of time. I got the edited things. I think it was like February 7th, and then I got the page proofs from the printer February 20th or something like this, and had to phone them in, and had an hour-and-a-half phone call and so on, making sure that everything would go correct. And then and this was the April issue, remember? And then I received the copy of the April issue, I think on March 25th, something like this. So Scientific American, when they have the April issue, it comes out the last days of March. And this is a little different from ACM Transactions on Graphics, where the October issue, I got the galleys in, and they were happy to be processing them in November and so on. But they do plan to have it out before the end of the year. This is absolutely necessary because the thing is a snowballing effect. You can see with the magazine Scientific American, if it would, as soon as the schedule would slip, then it would continue to slip and continue to slip. And so what is it, about eight articles per month? So 2 every week go through their doors and have to be in and out, and they have to get it done. This also accounts for the occasional lapses in the quality of the writing that I pointed out a few examples of on Wednesday. Let me show you another one. I mean, everybody can have their bad hours when they're doing a lot of things. This sentence, I should point out that here I have been discussing several algorithms, the sole purpose of which is to determine the best binary search tree. Okay, now I took out the hyphen between binary and search. That's another issue. That was, I was reading to you the words of the professionals, and it just sounded very awkward. The whole thing sounded awkward to me, and the sentences like this seemed very much like examples of the first approximation. And so now, in order to fix that up, I had to change a few things, which I think we're able to correct it without completely rewriting the whole thing. But what was my original sentence, I wonder? I don't know. But anyway, this was for me one of the most important paragraphs in the whole article, because most scientists, especially in 1975 when I was writing this, had hardly heard of computer science, and if they'd heard of it, they thought that computer science was there in order to promote physics or chemistry or whatever their science was as a tool for their work. They didn't see it as something that could be of interest to itself, and I was able to make a point here that computer science is a discipline because it closes in on itself, and that we have an algorithm who makes an algorithm that makes algorithms and improves algorithms. And so it was something that if you were only working on another field, you wouldn't think of having algorithms that would produce algorithms and so on. I was trying to get across the fact that algorithms is a study interesting in its own right and so on. And I see that my sentence had to be rewritten because I said we. I said note that we are speaking here about goodness, terrible things terrible sins I made here. Note that we are speaking here about algorithms whose sole purpose. Here I'm personifying an algorithm using a who to go with it and so on. I guess that would offend somebody. I always think of them as more identified. But anyway, so that sentence had to be rewritten, but it came out. What? Oh, that's right, I did. Hey, did it get in the real thing? That's interesting. Yeah. Let's see, where are we? Page 38. Okay, where are we? Optimum. Okay, so what actually did get in here? Yeah, the whose is in there. That's okay. We've made it here. We should point out that the preceding paragraphs discuss around whose sole purpose is to determine the best binary search tree. In other words, okay. So that made it through actually. Yeah. Okay. And the whole paragraph got really clobbered. It says the example helps explain why. In the study of how to properly employ computers, problems that are interesting in their own right arise, and many of those problems require a new and interrelated set of concepts and techniques. This was huge, long, awkward sentences and stuff coming out here. But everybody has their bad times, especially when they have to work under deadlines. And then I found out on this phone call that she was spending most of her time counting the letters in the lines so that the captions would fit and so on. Okay, now what? Let's see. To go on with the article, I think there were just a few more things in that text, and then I had okay. Now the rest of it I can show you on the other copies. Okay. Now in the original, I had suggested illustrations for them to use, and the first one was not used in the article, and it would be it must have been something that would be rather expensive. But I thought I wanted to start out with something that would be eye-catching and and also interesting from a historical point of view. And so at the beginning of the article, we were talking about how it's easier to find phone numbers in a telephone book if the names of people are in alphabetical order. And I wanted to point out that this was known in 2,000 years BC. And there's this, and then there's this table of reciprocals of numbers that was found from this point. Sorry, it's upside down. I should have planned that, but I didn't. Yeah. So the numbers actually in the cuneiform writing here are in alphabetic sort of dictionary order, and this was the first appearance I know of where things were really in order. And this is very remarkable numerical table from several standpoints. So I thought they might be able to get a photograph of this clay tablet from the Louvre, but that probably was much more difficult to do that and to worry about getting permissions and everything to be able to produce this. So that illustration was never used. But I still someday would like to think about making facsimiles of this particular tablet, because to me the task of sorting these quantities into order with the technology of the time was, I think it was the first time in history when a problem was ever solved, a data processing problem was solved that would have taken more than 1 second on a modern computer. And this tablet is sort of the result of that. And from this, I don't want to go a long story about the numbers, but if you look at the numbers, there was no way to generate those numbers one at a time. The only way to have done it is by putting together many pieces of data and sorting them into order, which would have taken a long time. If anybody has ever tried to sort 100 things into order, that seems easy on a computer, but when you go into thousands and so on, and these are multi-place things. It was something worthwhile. So it would sort of be a nice artifact for computer scientists to have some kind of replica of this old clay tablet. Well, but they couldn't use that illustration. I think that's the only thing I have marked here. In the page proofs, I showed you just a few things of the correction, but let me. Oh yeah. By the way, this got fixed okay because they changed less than or equal to less than when we were talking yesterday that I had less than or equal signs, but it turned out that less than was reasonable because the keys shouldn't be equal. What?
You left out Adams and Johnson. You left out the duplicates.
I left out the duplicates. Oh, yeah. Is that right? I see. Adams didn't. Oh, okay. Maybe that was what. Okay. I forgot that little detail. And I see. So when Adams is this grandson, John Quincy Adams, comes in, he doesn't get named in the database. I had forgotten that little detail. Let's see. How do we do it here? Oh, okay. Right. What? There's another Harrison. I mean I knew that Cleveland wasn't it? Was twice, but okay. So I see. So that's why I didn't have equals in there. All right. Okay. No problem. Okay. Now here I wanted them to use floor brackets and see if they could. Otherwise I would. But here anyway. I must have discussed this on the phone with her. And so they actually were able to do that somehow with their over there at Donnelly. They were able to shave it off. They don't look that great, but at least in any notation it's defined. So so it tells what the brackets mean there. So they were able to make that change. I got through over the phone. And there's just typo here and there. Now. Let's see. I'm sorry, I should be. Oh, but yeah. Speaking of brackets, they decided to use the grade school rule about putting square brackets outside of the parenthesis, and I said, please, square brackets have other meanings to people, but that correction did not get through. They still have the square brackets in the final article there. I forget why I had I put a yellow tag here. I should have remembered that one. No, I don't see any. It's just, I guess I was just to show what happens when a typesetter that's not used to mathematics gets into the act. What glitches happen. Now this actually they fixed it here, but here you see that little dash in there for the 2 to the k minus 1. Mathematics was really breaking them up, and I don't know how we got the. I guess by changing the word different to distinct, they were able to solve that one. But we had to resolve a bunch of these things on the phone. Now, here's a case where I had a subhead where it looked like it was falling in a bad place on the page, but I also realized that that it was better to put the subhead on the previous page, but just by seeing it here in a page proof. A lot of times you see things only after they're in proof, and so by moving that subhead here, this is where I really started talking about the idea that you can do better than the best. In other words, I've just been talking about optimum algorithms here, and now I say better than the best is subhead. As soon as something has been proved impossible, a lot of people immediately try to do it anyway, so I get into the idea that even though we've proved that binary search is the best way to do it, we're going to now show something that works better than binary search by changing the ground rules and saying that binary search was the best way to do it with comparisons, but there are ways to do it without comparisons, things like that. I believe that's what happened here. Now, bad hyphenation, that's not so important. Got to get half brackets in there. Okay. Here we had another communication problem with the that they talk about a subset, the empty set, and it comes out looking like, where are we here? Flowchart. I'm sorry. This is game with 20 questions. So this is here where you get the symbol for the empty set, and that's something that again causes problems when you're doing mathematical typesetting. You got it whenever you use this. Well, there are certain symbols that almost invariably get confused by typesetters who are inexperienced about it. Now, in this case, there was an L got changed to a 1. There were cases where, as I said, this cross 0 got changed to it came out okay in the final article. Got changed to a variant phi, and there were and another. I mean, in some fonts, it's almost impossible to tell the difference between kappa and X, and there's a bunch of other O's and zeros, obviously. So proofreaders always learn for that. But I wasn't accustomed to this kind of error. Here the thing just totally broke, and so we had to discuss this mathematics. Just their system went berserk. So we had to discuss it word by word over the telephone and make sure that we had the right number of letters in each line and all that. Okay, let's see. Don't have anything marked here. So most of the other problems were getting the mathematics straightened out, and I guess they must have called somebody else in on the job afterwards, because this was certainly a problem that they hadn't confronted before. So anyway, the final article came out, and as I said, they made these reprints which have been sold by thousands of copies. They worked surprisingly carefully on these reprints. Like they changed they give separate page numbers, and they reset the text to give you new page numbers in the captions, and this is in color, in 2 colors and everything. Pretty fancy. Now, this was the only article of mine that ever was translated into Arabic, or actually Farsi, Persian language, so that's another thing that's interesting. When you write, you'll get mail years later, which will now here I can't really tell much about what this says. I don't know if it's a great translation or not, but then in the footnotes I can tell where I can sort of keep up with them. And in fact, they even translated the Persian name here, which was he came from northern part of Persia at that time. But they have you see here, Taft gets in there and all this, and so it comes in. It's fun. What? Standard fortune? What? Yeah. Now this came out in Iran before the Shah was overthrown. You have to realize that. So, but then now in this is a right to left language. But when they get to mathematics, it goes left to right. Now you might say. That's the convention. Zohar showed me one of his math texts from Jerusalem and it was quite a elaborate book of mathematics, and it's all right to left, but the mathematics is left to right, and you switch back and forth. You don't have to do that with number. 20. You can say that's just a convention, that the ones digit comes first and then the tens digit. But when you get to other formulas, it goes that way. So let's see, what else was there on this thing? But typical in a translation that when there's a word uncommon in the language, they will show what the original, like quadrillion and so on. They weren't used to oil revenues yet at that time. Okay. And especially hashing. Now, hashing is the most funny word to translate into other languages that I know. When I wrote this book in French, they had to make a phone call to Paris, to the Academy, to find out and they found out that finally the word ashage had been produced. But there was a long thing, and there's a dictionary in the Math Library of Chinese English, the computer glossary of Chinese English. You look up hashing in there, and it translates into 14 characters. And so it comes out funny in other languages. Oh well, that's fun though. Now. The result of the whole thing, as I said, was painful for me at the time. I found that so much re-editing had to be done. But on balance, I was really happy that my article was shaken up to the extent that it was, so that I could do this. Otherwise, it would have come out in jargon that was invisible to me, and people wouldn't do it. In fact, Martin Gardner says that his greatest success, the reason for his success as a writer in mathematics, he has more readers, and he wrote to deadlines every month, had a column for 25 years, and had more. I'm sure more people have read his writings of mathematics than anybody else in the history of the world. But his success is because he's not a mathematician. The more he would learn about mathematics, the less successful he would have been. He was too much into it. So he could remain an amateur, but still very interested, enthusiastic, and with a network of people to send his stuff to check. But he never used too much jargon, because he never got too deeply into the field himself. So there's something that a person who's too much into it can never hope to achieve without professional help. Now, what did I slip on there?
It's professional help.
Professional help, yeah. Or without...
Counseling.
What, canceling out? What?
Counseling.
Counseling. Oh, counsel. Oh, okay. Yeah. Well, but the I think of writing also as a cooperative effort where we help each other, and this always makes the final result better, as you know. On the other hand, this paper that I submitted to IEEE was also edited by a copy editor. I'm not going to go through the long details of it, but I would hope that people would read the Stanford CS report instead. I mean, there was a case where the final report came out, and I just decided it wasn't worth the fight to put the thing back together again after they had destroyed it. Well, that was definitely my feeling anyway. But now I'll just show you a few of the points here. As I said, as I said the other day, they would never use 0 and 1 as a symbol in their articles. They always think you're supposed to spell them out, even though they're the IEEE transactions on coding theory. But one thing that they apparently had the policy in that journal is that log means log base 2 without further explanation. Now log is one of the most ambiguous terms in all of mathematics. It means log base 10. Everybody says these are common logarithms, and you just learn that they become extremely uncommon as soon as you pass 13th grade, right? Yeah. But they're the common logarithms. So log means log base 10 in most cases, unless you read something on number theory where it means natural logarithm, and if you read something on coding theory, it means log base 2, evidently. So I had used LG. That's my preference is to use in my books I always write LG for log base 2, and I had begun to believe that was catching on, but the editors changed that all the way through to log, and then gave no explanation what kind of logarithm they want. So then I had to say all logarithms here have radix 2, and then I said, please, not TWO, you know, but 2. This is not radix 2, and so I had to explain it here. Here was the case of unity that I mentioned the other day, that this term can be replaced by 1 at the expense of additional complexity. Okay. And so here I changed it to unity, better 1 as I had originally, but yeah, okay. Now, so that's just a little bit of that paper. So IEEE probably. Oh, well, I shouldn't say this. Never mind. I don't think they get the best copy editors in their staff. Let's see. Now, I had this Journal of Number Theory. I was showing you referee reports from that. I submitted to the journal because I liked the referees, but I didn't realize that how ugly their ellipses would look in their formulas. Look at that. Isn't this terrible? I can't. So this is something that just. You'd think somehow a journal that specialized in mathematics would have some feeling for typography. But the thing I wanted to talk about was the recent thing with ACM, mostly, because that's I think the most interesting issues. This is the article that I said is coming out in the October issue of the Transactions on Graphics, although it'll probably show up next month. And I thought some of the things the copy editor did here were shocking. Namely, data. Is data singular? Now, I think the word data, I don't even know how to pronounce it, but I know that it's one or the other. A lot of people think that data can never be used as a singular, and this was going on 30 years ago when I was in college. People said, you know, the word data is really a plural. and people abuse it by calling it singular. But so I started listening, and I found out that on both coasts and in the middle of America and everywhere, people were using data very consistently, and it meant something that was collective. It could be either singular or plural. And so when I published Volume 1 of The Art of Computer Programming, which came out to January '68, I was quite confident to say that this is a word that's used in both singular and plural, and I said so specific, there, and I used it that way all through that series, and I had copy editors, never changed it, and so on. So now I find out in 1987, I get back galley proofs from ACM saying that the original data have. I said has. And I'm thinking of it as a collective thing, and it certainly didn't mean it. I certainly didn't set any signals through my brain when I wrote this that I was doing anything unusual. And I certainly hear people talking and so on for more than 20 years now since the Art of Computer Programming was written, and besides, I'm sure that this is just common. So I changed the word to must, so that it's both. Must is the same verb for singular or plural, so that you don't have, so everybody's happy. But that's so. I wrote a letter to the ACM saying how shocking this was, and what ACM of all places should know about data, and then so I got a letter back, and where is it here? And but before I got the letter, I got a phone call, and actually Marilyn Salmonson is very good, and we had a long discussion, and it was very friendly and all, she said that McGraw-Hill uses data in the singular only in its computer science books. So they publish, it's one of the largest publishing outfits in the world, if not the largest, and they have the computer science books and everything else. And computer science books are allowed to use data in the singular. So that's so apparently so maybe I'm a member of a very small subgroup of the world where this happens. But then she said the New York Times uses data in both singular and plural, and this grieves her. So, well, the New York Times, my gosh, that's a pretty big outfit, and the New York Times is one of the most conservative in most ways on the way they do things. Wouldn't you say that, Mary? Carl? Yeah. That's a yes. Yeah. Definitely yes. They're very conservative. Yeah, extremely so. Yeah, and I mean, I get the International Herald Tribune, which is edited from the New York Times, and sometimes I get a free copy of the New York Times on my doorstep where they're trying to ask me to subscribe. But I get this other from Paris. Comes a little later, so I save the New York Times, and then a couple days later I get my International Herald Tribune, and the articles, and almost every sentence has a different construction in it, and I like it better in the International Herald Tribune, although they were originally written for the New York Times or the Washington Post. Well, so I know that they're extremely conservative. They have this huge big style book and everything, but they allow that in singular and plural. Now here she says academic press and IEEE transactions. Well, IEEE we can write off, but academic press. I'm an editor for academic press. I have to talk to the academic press people about this. Is this true in the Journal of Algorithms? Are they changing data to? Well, okay, I have to do it, but but you certainly can misuse it in a way that would be. And there are words like phenomena that I would be very reactionary. I would not, people. I also hear people saying, talking about this phenomena or something like this, and I know that it should be this phenomenon, that's somehow that's wrong. But that I know is okay. What's an automata theory is a problem because nobody says automaton theory, and it's not really usually good to use a plural in an adjective way. But is that okay? to say? Fine to have plural adjectives? Okay, well, that's good. That makes me a lot happier, because automata theory is definitely part of our language. Yeah. Automaton as a singular, automata the plural. Datum comes from Latin, and automaton from Greek. But they got these strange plurals. I guess I shouldn't go a long way about plurals there. Okay, so that was one shocking thing. Now here was another thing which got me. Since the class number of ij plus the class number of this are always equal to 63. Now that one I think is, so that one led me to another line of my letter to the ACM saying this is no. Now, in general, I thought that the copy editing was very carefully done, and in fact, remember I showed the galley proofs when they came in earlier this class, and I said it looked like they had a high budget operation and things were being done rather well. But then all of a sudden you see this, then I get this data that same afternoon I started looking at it and started wondering, so this one was definitely just a blunder, and everybody makes mistakes, and so she said, and very rightly, so we take pride in the care we give to the copy editing of the papers we publish. Admittedly, we make our share of mistakes. A plus BR was such an error, and I assure you that it will be corrected and all this. So yeah. But she still doesn't seem to be convinced about data, so I don't know what to do about that. We talked about it, and rather pleasantly. The other problem was something that I used the word. I used a million in the formula. I had this this quantity here, 1500 I plus j squared divided by a million. I didn't put any punctuation in there. I just said 100000 as I would in Fortran program. So they put commas in there because they have a rule saying when you have a number of more than 3 digits, it's more readable. Oh no, more than 4 digits. 1440 gets okay. Yeah. So if more than 4 digits, you've got to break it up somehow in order to be more readable. Now, to me, this is incompatible with being in a formula. There's two styles. There's a style in the text where I would write a million with commas, and there's a style inside a math formula where I would never put a comma. Certainly, at least I'd have to have 2 commas, because otherwise in Europe they would think it's a decimal point. So. Now they would prefer that I wrote 10 to the 6th. And that would certainly solve this specific problem. But what if the number hadn't been a million? What if it had been 1, 2, 3, 4, 5, 6, 7? What would you do? So she refers me to IEEE standard 268. Oh man, that makes me worry very much. But she says, for the sake of readability, insert spaces into the formula. So apparently, according to IEEE standard 268, if that number had been 1, 2, 3, 4, 5, 6, 7, I would have to put spaces in there, and that was supposed to improve the quality of the formula. Now I can see that this would be reasonable in a table where I'm presenting a lot of constants to a lot of to many figures, but I would find it very distracting to see spaces. And in fact, I even experimented with that when I was writing the tech program, and there's a bunch of places in the Metafont program actually where there are constants that have to be given to high precision, and I have a comment, and I tried putting thin spaces in, not great big spaces, just any kind of spaces, and it was uniformly worse in effect than putting the spaces in there. So on that, so there was another issue about mathematics.
If you write it as 1.23456 times 10 to the 7th, they can't put commas in.
They might still put spaces, though. Yeah, that would be. Since actually that's true, I could have divided the numerator denominator by some constant also there. Yeah, but In general, my feeling is that the spaces are useful when you have a context of high precision and tables and things like that. But otherwise, it doesn't seem to. It seems to be out of its element when this happens. Okay. Well, I've got 10 minutes to kill here, and I've gone through the things I brought. That's very embarrassing, but I thought you might know that I'm honest here. So what should we talk about?
I have a comment about data. My rule is I use data as a plural, as a singular if it's meant to talk about a collection of data as a whole.
Yeah.
And I use it as a plural if it's a bunch of pieces of...
The data given to our algorithm, yeah. But it's plural if it's a bunch of pieces of things. And so you say, here's a data. You won't say that.
Like datum, then.
What?
Datum, then.
Yeah. Mm-hmm. Right. Okay. That's good. Okay. I mean, we can always look for more examples in Scientific American in the article there, because it's full of changes. But that's the only thing I have here with me. So why don't we do that? Follow something through from the beginning to the end. Okay, I don't know. Should I start? I'm trying to think where I should go. Actually, one of the most interesting things was the algorithm at the end of that article. It's about so the idea of the article now is, I think I should say something about that. First, George Forsyth told me that a scientist should think once in his lifetime saying something to the non-scientific, to the general world at large, instead of or somebody outside of his own discipline. And it says that's the hardest thing to do. It's much easier to write for an audience that's like you and that you understand and so on. But when you're addressing, but sometime in your life you ought to think of trying to communicate with the larger public. And I remember he told me this shortly before he died, and it made an impression on me. And the year after he died, I spent in Norway and was asked to give a public lecture at the university there. And so this was the first time that I had faced the idea of giving a lecture to a non-specialist group. I was 32 years old or something, but I had always talked to computer scientists before. And I thought, okay, once in my life I have to do this, and I've done it 3 times now, but probably that's enough. I mean, I paid my dues for this. It's very difficult to try to have something that you yourself are real interested in, but you somehow don't understand the other people's mindset enough. But as I'm writing this article, I'm trying to make points about computer science, of course, that I get through. It's a story that's interesting to them, something that they can identify with, and that they'll get a feeling for computer science as a computer scientist does it, not as other people often view computer science. So I'm trying to present the spirit of the discipline the way I see it. It's just like, many people think mathematics is factoring polynomials, and mathematicians don't factor polynomials very often after high school. And computer scientists are people who write payroll programs, or they're people who make video games or something. I don't know. And that's all very interesting stuff, but not the soul of computer science as I see. And so I trying to get this across, and so I chose to present a sequence of algorithms for a certain task, and and searching is something that people could identify with. It's something that we always have to consult tables, and so I could get this across. And then so I could make a progression. I could start with a brute force algorithm, and then I could show that when it gets large, this brute force algorithm is going to be terribly slow. There's a better idea, binary search, and then I can show that we can improve on binary search if we know the frequencies of the elements that we're getting, and we can improve even further if we use a method called hashing, which is completely different from anything that a human being would ever want to do. So now to finally sort of clinch it, I mean, at least for the computer scientists who are still reading, then I said, now you can actually you put both ideas together. You can have hashing and ordering, and use the same, and use an algorithm that where you compute a hash address, and then you start comparing with less than and greater than comparisons instead of equal unequal comparisons as you do with hashing. And so this is the end of the article that I'm getting in here. Ambla was a man I met in Norway that year, and he came to me once, in fact, and said to me, Don, the story's even better than that. I wrote, after I gave this public lecture, I was asked to write a article for a journal called Forskningsnytt, which means Scientific Norwegian. I mean, it's the equivalent. It's the scientific publication for general scientific audiences in Norway, and so I wrote it. So this is really a rewrite of that article. In other words, I mean, the themes that I had in this article, this is much expanded over the one that was in Forskningsnytt. But literally, Forskningsnytt means research news, but it means it's like Scientific American. And Ambla was the man who helped me get it into good Norwegian. As I wrote a first draft, and I chose variable names like H and V and H instead of L and R for left and right when I was talking binary search. So in a way, I made my notation Norwegian. Because Venstre is left, and so you say V for left, your variable. But then Ambla looked at my article, and I had ended it with hashing, and he came and he said, Don, oh goodness, I just remember what I wanted to say the other 10 minutes. And he came and said, Don, couldn't you combine the ideas of searching, of alphabetic search with ordering with hashing? And I said, no, that's a foolish idea. It couldn't possibly work. And a few minutes later, I realized that he was absolutely right. And there was a beautiful algorithm out there, and we finally wrote a paper about it. But the main problem was I had just sent volume 3 off to be printed, and the section on hashing was all finished, and it was too late. The other point I wanted to make is that this was April 1977 when the article came out in Scientific American. That's the month I started working on tech. So these experiences that I had working with the publishers, seeing these galley proofs, and talking to the editors and so on phone, was leading me to focus on questions of type and typesetting in mathematics and the problems that were happening. And it turned out that that I guess it was the very beginning of May '77 when I actually designed. But in April when I designed the first draft of tech itself. But in April was when I had sort of made the decision not to spend my sabbatical working on volume 4, but to work on tech and on typesetting instead. And it was all all because of the concentrating on the words that we had here. Well, now let's see this. So to wrap it up, I was going to chase this through from the original draft to the copy edited version to the typeset. So it says the problem can be alleviated by combining the idea of hashing with the idea of alphabetic ordering as first suggested by O. Ambla in 1963. Now, what did the copy editor due to this. Page 54, 53, 52, 51, where are we here? Algorithm name. Okay, so didn't like the word alleviate. I don't know why. Maybe Mary Claire can tell why this was all changed around, but the sentence came out in 1973, starting at the end there. O. Amla of what institution suggested that the problem of the unsuccessful search can be alleviated by combining the concept of hashing with the advantage of alphabetical order. That was what came out of that one. Now, let's see. I guess, well, I'm not sure why my original sentence had to be changed. No. Usually I could figure out that there was some reason why, but here it just seemed to be perverse. Okay. So, suppose we have inserted the words X into the table in decreasing alphabetical order. Suppose that the 31 commonest English words are arranged in the table in decreasing alphabetical order. What? Oh, Mary? Yeah. Mary Claire, please push the... Okay.
I do know what it is. It's editorial policy at Scientific American to try to stress human contributions.
Okay.
If you notice that the two sentences put the contributor in quite different positions. You're more interested in the idea.
Yeah, that's right. Mm-hmm. Okay. So and that's a reasonable strategy for scientific writing. In fact, to point out that I mean, this was just 3-4 years ago, so people know it's a fairly current thing. All right. Scientific American had another editorial policy that said that they never display equations. This was one of the things that led to great problems. I didn't realize that when I was there. Okay, but that was enough about Scientific American. I think you see the pros and cons of this, but mostly the fact that everybody is working hard makes it finally come out with a good product.